Whenever we consider two straight lines on a plane, they either intersect or are parallel. If they do intersect at some point, we can see two angles are formed between them. One acute angle alpha and other an obtuse angle beta. Let's say we want to find this angle between the lines L1 and L2. How do you proceed now? These lines make an angle θ1 and θ2 with x-axis. If you see carefully, L1 should be rotated by an angle alpha to make it coincident with L2. This angle is nothing but the angle between L1 and L2 initially. So we have alpha equals θ1 minus θ2. Therefore, tan alpha becomes tan θ1 minus tan θ2 by 1 plus tan θ1 tan θ2, which is nothing but m1 minus m2 by 1 plus m1 into m2. Here m1 and m2 are the slopes of the lines L1 and L2. In general, acute angle alpha between two straight lines having slope m1 and m2 is given by tan alpha equals modulus of m1 minus m2 by 1 plus m1 m2. We know that if you are given a straight line with equation ax plus by plus c equal to 0, there would be infinite number of straight lines which are parallel to this one. But how do we represent them using equations? We know that slope of the line ax plus by plus c equal to 0 is minus a by b. Now, for any equation of the form ax plus by plus b equal to 0, the slope will again be minus a by b. Depending on the value of b, we get different straight lines, all of them parallel to our earlier straight line ax plus by plus c equal to 0. How about straight lines perpendicular to ax plus by plus c equal to 0? We saw that if two straight lines are parallel, they'll have same slopes. What about the relationship between slopes of two straight lines which are perpendicular? We know that angle between two perpendicular straight lines is pi by 2 and tan pi by 2 is infinity, which means modulus of m1 minus m2 by 1 plus m1 m2 is infinity. Simplifying, we get 1 plus m1 m2 equal to 0, or m1 m2 equals minus 1, or m2 equals minus 1 by m1. This is the relationship between slopes of two straight lines which are perpendicular to each other. So the straight line perpendicular to ax plus by plus c equal to 0 has a slope m equals minus 1 by minus a by b, or b by a. We discussed cases of two straight lines on a plane. That is, when they are parallel or intersecting at an angle. Let's now look at cases when we have three straight lines on a plane. As you can understand, there can be many cases when there are three straight lines. But we are particularly concerned about one case, which is when these three lines are meeting at a point. Let's take three lines given by the equations a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 equal to 0. By saying all these three lines meet at a point, we mean to say that there's one point x1, y1 which satisfies all these three equations. The other way of saying the same thing is by saying that the resultant area of the triangle formed by these three lines will be 0. As we know, the expression for area of the triangle, the condition for concurrence can be given by determinant of a1, b1, c1, a2, b2, c2, and a3, b3, c3 is equal to 0. Here, you have to take care that all three lines should not be parallel, as taking a determinant in that case will also yield a value equal to 0.